All right, here we go. 4.2, this is the second part. This is where we're going to go over examples number 5 and the practice problems from this example and example number 6. Let's check it out. All right, so you can see here that it is asking us to change to standard form. All right, change to standard form. And it's the one that we've talked about in 4.2. This is right now in point form, point slope form. So to kind of give you a visual of what it is that we're about to do is this. We already did changing it from point slope form into slope form. Into slope intercept form. Now the one that we're going to do is going to point slope form to standard form. Remember that standard form is where you go ahead and write your x term first, then your y term, and then the c or the constant goes by itself on the right hand side. Now, the funny thing is that even though we drew an arrow going that way, the route that we're actually going to take is we're going to go from point slope form into slope intercept, and then this is how we're going to get to standard form. Because if you look at slope intercept form, this piece right here, which is the part that has the x value, all you got to do is take that term to the other side, and that is when you're going to have your x term first. And that's exactly what we want, to have our x term first. So let's go ahead and get started with the example. Make sure you have your books to do the fill in the blanks, page 220. All right, so step number 1, you could see that they went ahead and this is, I explained it last video that the book likes to get rid of the fraction first. To get rid of the fraction, you're going to have to multiply by the division. The 5 is creating a division. This 5 right here is creating the fraction. So by multiplying, you are undoing what that 5 wants to do. So whatever you do to one side, do it to the other side. This 5 will cancel with this 5. And what you're going to be left with is you still have this 5 outside. When you still have that -2, sorry. When you cancel the 5, you still have that -2 that needs to be distributed, right? So we now have to do the distributed property. And when we distribute the 5, we get 5y minus 5. When we distribute the -2, we get -2x minus 6. Next, what's the next step? Well, the next step is to get our numbers where we want them to go. Remember that we want to get this right here to the other side. And we want to get this right here to the other side. Okay, so how do we get the 5 to the other side, that -5? We would have to add 5 to each side, right? That's a property of equality. And then finally, we would want to take this 2 right here to the other side, which we already said before, by addition. So what do we get at the end? We get 2x plus 5y equals -1. Remember, this is the order that we want it. We want the x to go first, then the y term, and then the number without the variable or the constant alone on the other side. All right. So let's go ahead and do a problem right here to check the understanding. Pause and try it on your own. Go ahead and write this equation, which is already in slope intercept form. Write it in standard form. All right. So I'm going to tell myself that I want to write it in standard form. Standard form is where we have the x term, then the y term, and then a constant by itself. So what I'm going to do is I am going to show you what the Carreño method is and what the book version is. Carreño will just say, guys, open your eyes. All you want to do is get the x term, which is this one right here, take it to the other side. So it's to the left of y, right? To the left of y. So that's exactly what I'm going to do right now. I'm going to go ahead and say, let's go ahead and add 7/2x to the other side. So 7/2x to the other side. And now we should be done. Everything will be exactly where we want it to be. Anything minus itself cancels out. And now we have 7/2x plus y equals 5. And we're done. Okay, so how do I know I'm done? Because my x term goes first, then the b term goes next, and then my constant term is last without the variable. Okay, now let's see what happens when we do it the way that the book tells us to do it, or suggests to do it. The book suggests to get rid of the fractions right away, or pretty much attack that denominator. So in this case, the book would suggest, hey guys, let's go ahead and get rid of this 2 by multiplying everything by 2. But remember, the 2 on the bottom of this fraction cancels out, but you still got to distribute it in here. Okay, so what do we have? In this, 2 times y is going to be 2y. And then here, the negative 7x is still left because the 2 canceled out. 2 times 5 will give us 10. That's what we have here. The last step would be to get 7x on the other side because 7x is the term that has the x variable. So as soon as my 7x cancels out here, I will then have it on the other side. And here we go. Ta-da! So we have 2 different things here, right? It seems like they're different. You should be asking yourself, how come this is what you're showing us? Well, let's talk about it really quick. Right here in red on Desmos, we have the original line that's given to us right here. Negative 7 over 2x plus 5, right? It's in red. Now, the one that we created is this one that we see right here, 7 over 2x plus y equals 5, which is right now in Desmos, the blue line. Look at it. It's the same exact line. So is the book wrong by saying that the answer is this right here? This right here? Well, there's only one way to find out. Let's see what happens when we graph what the book wants to graph. Look at that. Same exact line once again. So what's the difference? Or how is it that these 2 things are the same, even though they look completely different? It looks like they would make 2 different lines since these are 2 different types of equations. Well, hopefully I can answer that question by explaining to you fractions. Imagine the fraction 1/2. 1/2 is the same thing as many other fractions, like 2 over 4, or 3 over 6, or 4 over 8, right? All these fractions are equal to each other. And that is because we understand that if we grab this fraction, or any of them, and if we say, okay, let me multiply this by, say, 2, if I multiply the top and bottom by the same amount, by the same factor, I create these values here. That's what makes them proportional or equal to each other. Well, what happens if I multiply it by 3? Well, then I make this and I make this. What happens if I multiply it by 4? Then I make this and I make that. So if we stay true by multiplying the entire thing by the same amount, by the same factor, then it remains the same value, this equivalent. So what do you guys see that you can multiply these numbers by to become these numbers? Vice versa. Doesn't matter which way you want to go. Well, my brain tells me, look at the number 5. It's the easiest one to compare. And the number 10. How do you think 5 becomes a 10? By multiplying by 2. So if you want to go, let me go ahead and erase this arrow right here. If you want to go from this equation to that one right here, you would want to multiply by 2. And hopefully that makes sense because this is a 1. And if you multiply that by 1, you get 2. And then 7 over 2, if you multiply that by 2, you get 7. Now, the same thing happens if you want to go backwards. You still multiply by a number, but that number is half. 1/2, right? Something tells me you guys like the number 2 better, so multiplying by 2. So these 2 equations are equivalent because of that idea. Do you want to do a Carreño's method or do you want to do the book method? That is completely up to you. All right, so I'm going to go ahead and complete all of these questions on the board, and I'm going to do it kind of quickly because now you guys have already seen it in class, and now let's go ahead and go a little bit faster. So write each equation in standard form. So the first thing that I see here would be the distributive property. I'm going to have y minus 10 equals 2x. 2 times negative 8 gives me negative 16. Okay, what do I want to do now? I want to do 2 things. The first thing that I want to do is I'll take the x term to the left side, and I also want to take, so let's go ahead and do minus 2x on this side. But another thing that I want to do is to take this 10 to the right side. Okay, so I'll do those 2 things at the same time, so we're not wasting space writing stuff. This 10 is going to cancel out, and this 2x is going to cancel out. Now, let's go ahead and write our equation in standard form. This negative 2x, I'm going to go ahead and write it first. Plus y equals, and what do we have? Negative 16 plus 10. That's going to give me a negative 6. So I want to stop you guys right now, and I want to tell you the second thing we're going to learn today. What was the first thing we learned? Well, we learned that two equations can be equal even if their numbers are different. Okay, as long as we could see what factors we're multiplying from one to get to the other. What is the second thing that we're going to learn today? The second thing that we need to learn today is how does a standard equation, a standard form of an equation, get simplified? Well, for some reason, somebody said, we don't like the first term to be negative. Okay, so what do you want me to do? I already got an answer. What do you want me to do? Well, multiply by a -1 so it becomes positive. Well, that's kind of petty, but that is how they do it to make it positive at the beginning. So pretty much, long story short, all their symbols, everybody's sign just flips. Anything that was a negative becomes positive. Anything that was a positive becomes negative. That's it. So if you write this one right here in your quiz, that's fine. I will give you the points. But if you write the one that the book gave, that's awesome. That means you understand that there's one tiny little thing that we could do to make it perfectly in standard form. All right, now that we understand these two rules, we can go ahead and move a little bit faster, understanding that these things apply. So y plus 7 equals -3/2 times x is -3/2x. I don't know why I just put the parentheses there. And then we got a negative times a positive is a negative, and 3/2 times 1 is just 3/2. All right, so let's talk about this. What do we see here? We can see that this 7 needs to go to the other side by subtraction. So here it is. And we could see that the -3/2 needs to go by addition. Okay, so that's what we have. Now let's go ahead and cross out anything that cancels out. My fractions right here cancel out, and the 7 cancels out from this side. Let's go ahead and start writing this in standard form. Standard form tells me that the x term goes first, then the y was just a 1y. And then lastly, let's work with this fraction. We have -3/2, okay? And we want to take away 7 from it. But let's be smart. Let's figure out what fraction is equal to 7. So what fraction is equal to 7? That has the same denominator as my other fraction, which is a 2. So what fraction is equal to 7 that has a denominator of 2? What divided by 2 gives us 7? That's the number 14. Okay, so now that we figured that out, we can actually subtract fractions easily, because whenever you have the same denominator when adding and subtracting fractions, it stays the same. And now all we got to do is -3 minus 14. Ooh, -3, -14, -3, -14. They are both negatives, so they're going to team up to make more negatives. Whew, all right. That's the answer right there for after our equal sign. -17/2. Boom. Done. Seems like we finished it. Okay, now, if you did not like that because it had too many fractions, remember that you can do the way that the book does it. Now, look at what the answer would be if you do it the way the book does it. Okay, what I would encourage you to do is I would say, hey guys, do you see that my y value right here is 1 and the y value right here for this one is 2? What do you think you multiply mine to get to that one? You would have to multiply by 2. So you would see that it's consistent. If you graph this on decimals, these two lines are equal to each other. They're same line. So this is the correct answer, and this is also the correct answer. It just determines, whatever route you decided to take, it's what answer you're gonna get. All right. So question number 16, I left it as cranial method, meaning we're dealing with fractions. Question number 17, I'm going to do book version, meaning I'm gonna get rid of the fractions as soon as possible, and whatever happens. So the fraction that we have here is 1/3. What's causing the fraction is the division of 3. So I will multiply both sides by 3. What happens here? This 3 will cancel out with this one, and I don't have to apply it in here. I don't have to because of the parentheses, how the grouping is doing. This 3 is only going to apply out here, and then whatever results from that will then be applied inside. Okay, so that's the way it works. It goes, this number deals with that one, and then that deals with inside. So we don't have to do double distribution here. So that 3 just goes away with that one. And then I do have to distribute here and see what I get. All right, so I will get 3 times 2 is 6y. 3 times 3 is 9. Over here, we get that negative 1x. Oh, sorry. Negative 1 parentheses x minus 2 close parentheses. As you can see, all I did was cross out the 3 and wrote everything else that was standing. Can you see that we can distribute this negative here, make these terms opposite signs? So 6y plus 9 equals negative x plus 2. Okay. Now, I don't know what you're thinking, but it sure beats the way that this one looked, even though this is the way Carreño teaches it, because I don't want to change the steps that I teach you guys. These numbers just seem a lot prettier. All right, what would we have to do here to make this in standard form? Well, for sure, this x has to go to the other side because that's the first thing that goes in the order of my standard form. And this 9 needs to pair up with the 2 with my constants without the variable. All right, so let's write it out. These x cancels. We now have x plus 6y is equal to negative 7. Done. All right. Let's see what we got here. X plus 6y is equal to negative 7. Cool stuff. Okay. Now, 18. All right, so for 18, there are no fractions. So we can just do the distributive property here, not worry about whether we want to get rid of fractions or not, because we don't have any. So right away, distributive property. Nothing happens to the left side of the equation. Here we have 3 times 4 is 12. 3 times negative 2 is negative 6. And 3 times 1 is 3. Cool. All right, so next thing is pretty much combine like terms. I know that my the values that I want on the left side includes the 12x. So I need the 12x to be on the left side. Okay, it'll combine with this one. And then also, the 6y needs to go to the left as well. So plus 6y. This will put everything where it should go. All right. All right, so what do we got? I want to write it in standard form. So I'll go ahead and deal with these numbers first because these are my x numbers. Negative 5 minus 12. They're both negative, so they're going to make more negatives. They're going to make negative 17. Then I got 4 right here plus 6 in my y's. That's going to give me a total of 10 y's. And then on this side, 12's canceled, 6 canceled, still just a 3 chilling. All right. Is there anything here that you think might look different in our answer? The answer should be yes. We could multiply the entire equation by negative 1 so we can make the leading term a positive because somebody along the way said it looks prettier when it's positive. I don't know. I don't know. All right, let's look at number 9 and numero 10. All right, number 9 and number 10, 19 and 20. Whoops, that's cut off there. 19 and 20. For 19 and 20, hopefully you guys can agree with me that if we just want to put it in the ax plus by equals c format, pretty much just look at where your x is located. We need to get it in front of y. Look at where my x value is located. We need to get it in front of y. So this is pretty much a quick take x to the other side by subtracting. And what we're going to have here is negative x plus y equals 1. The only thing, and we're pretty much done. It's already in this format. The next thing, or the one thing that we could do to make it positive or super simplified would be multiplying it by negative. So I'll have a positive x, a negative y, and a negative 1. Is that what the book wanted? There it is. Okay, let's look at this one. So Long story short, I don't know if you need me to write it. I don't think you need me to write this, but this is going to be a negative 1/3 to the other side by subtraction, followed by a plus y equals negative 10 on the other side, where this is already in standard form. But if we want to put it where our leading term is positive, we'll multiply by a -1, making it a positive 1/3, and then negative y, and then a positive 10. Now, I hope you see that this has a fraction, so the book might get, not might, they probably did get a different numbers. And here are the numbers from the book. Hopefully you understand that 1 times 3 is 3, -10 times 3 would be 30, and you're going, no, it's not 30, it should be -30. Well, remember that they kept it. This is a positive, so I guess you can call it times -3, right? Times -3. Remember that we wanted to multiply by this -1, right? So make everybody positive, or I'm sorry, the leading term positive. So long story short, let me just take all this stuff off. We got it right. Okay, if we put it on decimals, if we put the one that we got and the one that the book got on decimals, they make the same exact line. So don't freak out. We're cool. We're good. Let's move on. All right, number 6, example number 6, standard form with given 2 points. Okay, so when we get 2 points, they want us to make it into standard form. Let me give you a visual. Let me give you a visual of what we're about to do right now. So let's do x minus x1 equals, no, it's not x minus x1. It's y. Y minus y1 equals slope times x minus x1. Okay, so here's a visual about what's about to happen right now. The visual is the following. They're going to give us 2 points, as you see right here on the top. And what we need to do is we got to take one of 2 routes. We can either go this way and then go this way. That's route number 1. Or the other route would be from our 2 points, go this way and then go this way. Okay. Now, both routes will work. Whatever your heart desires, it's going to be okay. Now, the book will take us this way. We'll go this way. And that's pretty much where my brain will also go, because I always think slope-intercept form is just the cleanest and the one that's, I don't know, it seems like it's, for some reason, just look at the amount of stuff that's in here versus the amount of stuff that's here. I don't know. For some reason, it tells me that that's what I want to do. If you guys look at your book on page 221, the thing about it, it tells you that you can do both of those routes. Okay. The book will tell you to do it in the slope intercept, but they are saying, hey, you can also do it in point slope form. Okay. And I know they put it as a question, but the answer is yes. You could put it as point slope form. All right, let's go ahead and fill in the blanks. Write an equation in standard form in the line that passes through those 2 points, for the line that passes for those 2 points. All right, so you have 8, -4 and -6, -11. What we want to do here, if we want to put it into slope-intercept form, then we obviously need a slope. That's called slope-intercept form because we need the slope. Now, let's go ahead and you can label your points x1, y1. The book decided to label them like this. And you put them into your slope equation. They got -7 over -14. When you simplify that, we get 1/2. Okay, so we got a slope of 1/2. What do we want to do now? Well, let's now find b, which is the y-intercept. This is what they're telling us to do. Find the y-intercept with the x and the y of whatever point you want to choose. Right now, the points that the book is choosing is 8, -4. It doesn't matter. You got the option of 8, -4 or -6, -11. You choose whatever you want. So this is the flow of the work. Follow it. You could see that the y value of our point was -4, located right there. Our slope that we found out was 1/2, and the x value of this point was 8. So you plug in those points, you do 1/2 times 8, which gives us 4. Take 4 to the other side by subtraction, and that will give us y-intercept of -8. So now you can go ahead and plug in those numbers that we got. you plug in our slope of 1/2 right there and the y-intercept of -8 to get this equation of the line. Y equals 1/2 x minus 8. The final step is just move stuff around so you can get it in the standard form way. The standard form way is to pretty much just get the x, on the other x first, and then the y, and then the term without the variable. So what did the book decide to do? The book decided to get rid of the fraction first. Remember, when you get rid of the fraction, that means you got to multiply it by the denominator. So you're going to have to do this and this. Why do I distribute in this one? Why do we have 2 arrows? Because there's no grouping. There's no more parentheses in here. So you do have to give the multiplication to the 8. So when you multiply the 2 times the 1/2, these 2's cancel out. So you're left with just the 1x or just x. And then the 8 becomes 16. All right, what happens next? Well, now we need to take this x to the other side. How do you take the x to the other side? By subtraction. That's a positive x. But look what happens. You now have a negative x at the beginning. Oh my gosh, the world's going to end. No, it's not. That's good enough. But the book just wants to simplify one more time. Just multiply everybody by -1, which flips everybody's symbol. That's it. That equation is written in standard form, and it goes through those 2 points that they gave us at the beginning. Whoa, crazy stuff. Moving on. All right, check problem on page 221. Pause it right now and try it on your own. Here we go. So select the equation in standard form for the line that passes through these 2 points that are given to us. Now, here are the steps that they gave us. Step number 1, we need to find the slope. Okay, we need to find the slope. The way that we can find slope is by doing y2, so -12. I decided to call that my y2, by the way, and this is my y1, so -12 minus 8, minus 1, sorry, not minus 1, over 1 minus -9. Minus -9 is the same thing as adding. So -12 minus 8, that will give me -20. And 1 plus 9, that will give me 10. So when I divide this, I get -2. That is my slope. My slope is 2. M is 2. Okay, that's step number 1. Step number 2, if you go back and you look at the steps, it says go ahead and write it in slope intercept form when it says this right here. Step 2 should actually say look for your y-intercept. That's what it should say. The reason is because we already have everything else. And the only thing we don't know is the y-intercept. We have a y that we can work with. We actually have 2 of them. We have 8 and -12. So not only that, we have the y from the 8 and -12, and we also have the x from the -9 and 1. So we have that. We have the y, the x, and we just found the slope. And that goes right there. Okay, so right now you go ahead and flip a coin and you decide which point you want to put in there. It doesn't matter. I kind of like the 1 and -12 just because we have a 1 in there. So I'll go ahead and use those points right here. My y is -12. So -12 equals the slope of -2 times the x value of 1, which nothing changes, is b. So let's do this math. You can see that this is all set up so we can find b. Nothing changes here. I'm just going to get rid of the parentheses. -2 times 1 is still just -2. We'll take -2 to the other side by adding. Adding 2. Our 2's cancel. And now we have -10 is b. b is -10. Woo! So we pretty much now have everything we need to write our equation in slope intercept form. Okay? When we write an equation in slope intercept form, the y equals mx plus b, this one right here, the 2 items that we actually write in is the slope, and the y-intercept. Those are the 2 items that we write in, and that is what makes our equation. So y equals, what was the slope? -2x. What's the y-intercept or the b? -10. Whew. Yeah, it's a lot of work. I know. Sucks to suck. Our last step is to make sure that we rearrange everything so it's in standard form. Standard form is when our x term is the leading term. So we would have to add 2x to the other side. That means our final answer is 2x plus y equals negative 10. I already know that this is my final because the 2x is positive. That's my leading term. It's positive. I don't have to multiply anything by negative 1. So I'm good to go. My answer here is 2x plus y equals negative 10. And that is going to be letter D. All right. So at the top of the screen here, maybe you noticed, maybe you didn't. There was a little thing that said cheat code. What is the cheat code? This cheat code is actually what you guys learned in the last problems of 4.1, which is very interesting. 4.1 shows you how to determine whether a point is on a line. So can you guys actually tell me if this point is on this line or if this point is on this line? What do you do? What do you do to show that a point is on a line? To do that, to show that a point is on a line, you need to, and we already know that the answer is D, so I'll go ahead and do it with this one. You need to grab your equation, 2x plus y equals negative 10. And why am I putting parentheses? Well, I'm putting parentheses because I have an x and a y here that I want to input to check to see if that's true. I want to, my points will make the equation true. The points of the line will make the equation true. So this is x and this is y. When you multiply this together, you'll get negative 18. Whoops, plus 8. That gives you negative 10. So it makes this true. What does that tell me? That this point is on that line. So what that means is I know that this point is on that line. So now let me check this one, which is 2 times 1 plus negative 12. 2 times 1 is 2 plus negative 12 means just minus 12. 2 minus 12 is negative 10. So it does equal negative 10 as well. These 2 points are on that line. This is the only line, and you would be able to check, you can check that this is the only line that will make both of those points become a true statement, a true sentence. There we go. If you want to try it out with other ones and see that they're not going to make it true, try it out. But that's the cheat code. All right, here are the last example problems, 21 through 24. And then I think we stop there. Yep. All right. Write an equation in standard form for the line that passes through the given points. So what I'm going to do is I'm going to grab all this. We're going to move it down. We're going to go quick, people. So if you didn't put in your fast pants today, I don't know what to tell you. The first thing we want to do right now is find slope. So slope is, I'm going to go ahead and say that negative 7 is going to be my y2. So negative 7 minus negative 3, so plus 3, divided by 4 minus negative 2, so 4 plus 2. Negative 7 plus 3, that's going to give me negative 4. Over 4 plus 2 is 6. The only thing that I can do here is kind of just reduce this to negative 2 over 3. Okay, now that I have slope, I'll go ahead and say, okay, well, let me grab one of my points here and put them in my y equals mx plus b, so we can find the y-intercept. I said that I was going to choose that point right there that I underlined. So my y is negative 3. My slope is negative 2/3. And my x from that point is negative 2. And then we're looking for b. Okay, so negative 3 equals, the multiplication here is just negative 2 times negative 2. That's going to give me positive 4. So it's going to be 4/3 plus b. What do I do here? I take 4/3 to the other side by subtraction. So minus 4/3 minus 4/3. Cancel, cancel. Okay, so look at what we're doing. We're doing negative 3 minus 4. Whoops. Negative 3 minus 4/3. What we want to do here is change 3. I want to change 3 into a number that is equal to 3 that has a denominator of 3. So what number has a denominator of 3 that equals to 3? And that would be 9. Okay, so we actually have negative 9 minus 4. Negative 9 minus 4. That's going to give us negative 13. We're going to keep the same denominator. Woo! This is a lot. All right. So this right here is our, whatchamacallit? Y-intercept. So let's go ahead and say again, y equals mx plus b, writing it with the information that I want to input. I want to input the slope and the y-intercept. So here it is. Y equals, what was my slope that we found? Negative 2 over 3 x, and then b was negative 13 over 3. Eesh, this is ugly, but we got to do what we got to do. All right, our final step is take 2/3 to the other side by adding. That will make 2/3 go away on this side, and we now have 2/3 x plus y is equal to negative 13 over 3. Wowzers. And there we have it. Cool. All right, so you guys can already see that I'm not going to sit here and do all of these because this will take a long time. It's 4 of them. This is the ones that you got to practice. But what I do want to do is I want to check this out. I want to see how, because I know the book did it differently than me. So let's go ahead and see how that looks like on Desmos. So let's first put the points. Let's see all of it. So let's put the point -2, comma, -3, close. Oops. That's that point right there. We also had a point at 4, comma, -7 right there. And now let's put the book's answer. 2x plus 3y equals -13. Bam. Okay, no doubt about it. They created a line they created an equation of line that it goes through those 2 points. Now I'm going to go ahead and hide that. Let's put what we came up with, which looks ugly. 2/3, and this is why Carreño's method sometimes is, even though I tell you that this is the way that I always do it, no matter what the numbers look like, this is it. Not over 2, over 3, over 3. There we go. There you have it. You can zoom in as much as possible. And I want to show you that I did put a 2 before by mistake. I typed in a 2. Oh, never mind. I was going to say it might have looked like it was very close by, but same exact line, same exact line. So when you start to wonder what it is that you got to multiply mine to get the one up top is, check it out. If I multiply mine by the number, because this y right here, why is this freaking out? By 3. Oh, okay, sorry. This is just extra stuff. If you already understood it, then that's fine. You know what? No, this is way too much. It's tripping out. All right. Long story short, it all checks out. Okay. If you have a doubt in your answer, do what I just did. Type your answer into Desmos and see if you get it right. If not, you're going to have to backtrack. That is the way that you have to do it. Another thing that I do recommend, if you're struggling with this, do the book method. This part right here with, is it that part right there? No, not that part right there. Yeah, I don't want to. Do the book method if you are struggling with these fractions, okay? Here are the answers for 22, 23, 24. And remember that what you're going to come up with if you use my method will look different, and it's okay. There are your answers. Good luck. Peace out.